Hello everyone, today we're going to be talking about grid walking, which is a very important concept in many counting and probability problems in many math contests. However, before we get to that, let's talk about last week's homework problem, which was about sticks and stones. And if you want to skip this or just want to go to the answer, skip to this timestamp. So, in this problem we have 7 dices, so 1, 2, 3, 4, 5, 6, 7, and then the sum of the numbers on these dices is 10. So the key in this problem, to turn it into a sticks and stones problem, is instead of rolling the dices and then counting the sum of them, we can pretend like we're giving 10 points to each of the 7 dices. And then we can see how many ways there are to do that. So first, we know that the dice can only roll the numbers 1, 2, 3, 4, 5, 6. The important thing here is it cannot roll the number 0. That is not possible. So remember how we did this in the sticks and stones class is by just giving 1 point to each of the dices beforehand. So we have the 10 points, and if we give each of the 7 dices 1 point beforehand, we have 3 points left to give freely. And now just a sticks and stones problem. We have 3 points to give, and we have 7 dices. And that is just 3 objects giving, and since there's 7 dices, there's going to be 6 barriers in between them. So 9 total objects, choose 3, and this is equal to our answer of 84, which is answer choice E. So the first question is, what even is grid walking? Well, basically it's the way of how many ways you can get from one point to another point on a grid, traversing the grid through these edges, and in the least number of ways possible. And usually there's some restrictions, like you can only go to the right and up, and you can't like backtrack. So that basically is a fancy way of saying, oh, you can only go to A to B, in this case since it's a 3x4 grid, in 7 steps. So now let's see how we can solve these types of problems. Well, there's 2 ways. The first way is slower, but it's more versatile and easier to understand. And the second way is much faster, but can't be used in all problems, and is a little harder to grasp. So let's start with the first way. The key takeaway from it is if you have a point like here, since you can only go to the right or up, you know you have to come from this point over here, or up from this point over here. So the number of ways to get to this middle point is the number of ways to get to this point here, plus the number of ways to get to this point here. So we can just go out throughout the grid and see how many ways there are to get to each point. So we start at A, so let's just say there's one way of going to this point. And since this point over here doesn't have any point below it, it's just going to be how many ways there are to go from A to that point, which is just 1. And the same for this point. And using that same logic, we can go throughout this whole row. Because notice we can only go to the right, or we can go up. So there's no other way of going to these 7 points without just going straight to the right or straight up. And now here's where it gets interesting. Now for this middle point here, we can add the 2 points next to it. So this will be 1 plus 1 or 2. And now we just keep doing this. So 2 plus 1, 3. 3 plus 1, 4. And then here we do 2 plus 1, 3. 3 plus 3, 6. 6 plus 4, 10. And this may look familiar. 3 plus 1, 4. 4 plus 6, 10. 10 plus 10, 20. And then 4 plus 1, 5. 10 plus 5, 15. And finally 20 plus 15 is 35. And remember what these numbers represent. It's how many ways there are to get from A to that specific point. So now we know there's 35 ways to get from point A to point B, because that's what we just found out. And now let's do the second, quicker, but a little harder to understand way. So we know there's going to be 7 steps in this path, because we can only go to the right and up. And as we can see, this is a 3x4 grid. So since there's 7 steps, and it's a 3x4 grid, we're going to have to go eventually right 4 times, and then up 3 times. So now the question is, how many ways are there to arrange this? And that's basically asking how many different arrangements of 4 R's, so 4 rights, and 3 ups, are there so we can go from A to B. since you have to go 3 up and 4 right to get to B. And this is just equal to 7 choose 3 because all the rights are the same and all the ups are the same. And this is just equal to 35, which as we can see is the same as the answer we got before. And this should make sense because it is the same thing we're finding out, how many ways there are to get from A to B, however just in 2 different methods. However, as you can see, the second method took so much less work than the first method. So now let's solve difficult problems with them. So here is problem number 21 from 2020 AIME C8. And reading through this, we're starting at P, and we have to go to Q, and we can only take 7 steps. And looking at this more closely, we see that the least number of steps we have to take is 7. So we have to go most optimally to get to Q. And as we can see, I'm drawing it out. Here's another 7-step path. So we have to be as optimal as we can going to Q. We have to go straight up. So this looks, as I said, very different from the grid walking problems we were doing before. However, this is a grid in disguise because it is just a grid but rotated. As you can see, this is 3 by 4. So this is actually a 3 by 4 grid that is hidden in plain sight. And the trick with this is that this white square should be here and this white square should be here. So there are some squares missing, however, we can deal with this. So since there are some squares missing, it is hard to do the second method we talked about before. So let's do the first method, which takes a little longer but is very reliable. So again, there's only one way to start because we're starting at P. And just as the same, we can just label the sides that are connecting to P as 1 because we have to be very optimal. We can only take 7 steps as the problem says, and that is the least amount of steps we can take. So there's only one way to go across these diagonals. And now, time for the fun part, adding. So this square here, 1 plus 1, 2. And now we just go up, 2 plus 1, 3, 2 plus 1, 3, 3 plus 1, 4, 3 plus 3, 6, 3, 6 plus 3, 9, 6 plus 4, 10, 9 here, 10 plus 9, 19, and finally 9 plus 19, or 28. And we get our answer of 28, which is A. Thanks for staying around till the end of the video. So today we learned about grid walking, which we learned 2 methods of solving. Method 1 was that going through the grid, adding up the corners that were next to each other into one corner, and basically doing that all the way till the end of the grid. And method 2 was for simpler grids, which you could just define your path as steps like rights and ups, or if you're going the other way around, lefts and downs, and just rearranging the multiple R's and U's to find how many ways there are to go from one point to the other point. And as your homework for today, here is a problem. So how many ways are there to go from A to B, but you cannot go from this point to this point directly? And a hint, method 1 is really simple for this problem, but may take a while, so maybe think of a way of doing method 2. So I will talk about the solution to this problem in the next video of this series, and thanks for staying till the end.